Hello everyone. In this video clip, we are going to discuss an important topic which is need of modulation. Modulation is a process which takes place on the transmitter side in a communication system. To understand what is modulation process, we will first discuss what is the need of modulation. Why do we need to carry out modulation process on the transmitter side? An inverse process which will take place on the receiver side will be called demodulation. To understand the need of modulation, I will take a very simple example of a radio communication system in which we have a radio transmitter and a radio receiver. Because it's a radio communication system, the channel of transmission, which is nothing but the medium through which the transmission of signal will take place, is wireless in nature. For any wireless communication, we always need antenna on the transmitter side to transmit the signal and antenna on the receiver side to receive the signal. The signal that we are going to transmit will be called information signal. So please remember that the aim of the whole communication system will be to transmit an information signal from transmitter side to the receiver side. The transmission takes place through a medium which is called channel. In this case, the channel is wireless in nature. Since it's a radio communication system, the transmitter will be transmitting the signal which will consist of audio frequencies. That means it will be the signal that will be audible to the humans. Now, the range of frequencies which are audible to the humans consist of frequencies from 20 Hz to 20 kHz. So please remember this range of frequencies. These are called audio frequencies. If any signal consists of these frequencies, that signal will be audible to the humans. So transmitter will be transmitting signal consisting of frequencies from 20 Hz to 20 kHz to the receiver side. Now, let us try to figure out what are the problems which we face in the setup of this communication system. And to overcome these problems, we will have to take the help of modulation process. So we will discuss all the problems first, and at the end of this entire video clip, it will be clear that why we need something called as modulation, and we will also somewhat answer the question that what is the modulation process, which we will anyways discuss in detail in the video clips after this one. So let's start everyone. The very first problem that we face is something related to the size of the antenna. From antenna theory, it is known that for the transmission of any signal as well as for the reception of a signal, the size of antenna should be of the order of lambda by 4, where lambda is nothing but the wavelength of the signal which is given as C by F, where C is the frequency of light, which is 3 into 10 raised to 8 meters per second, and F is the frequency of the signal which is being transmitted or received. So let us calculate the value of lambda for one certain value of the frequency, let's say 1 kilohertz, which is 1 into 10 raised to 3 hertz. If we work this out, lambda comes out to be 3 into 10 raised to 5 meters. Now, even if I take lambda by 4 value, it will be 3 by 4 into 10 raised to 5 meter. As we can make out, this value is very large, which means that to transmit or receive the frequency of 1 kilohertz, we will need an antenna whose length will be of the order of 3 by 4 into 10 raised to 5 meters, which is 3 by 4 into 10 squared kilometers, which makes it very clear that we cannot have a practically antenna of such a large size, and hence the transmission of frequency of 1 kilohertz will not be possible. Not just the frequency of 1 kilohertz, if I take any frequency from the range 20 hertz to 20 kilohertz, the wavelength of the signal will come out to be very large. That is simply because all the audio frequencies that we have in this range are very small frequencies. If the frequency of transmission or reception is small, its wavelength lambda will be large, because as we can see, wavelength and frequency are inversely proportional to each other. If the wavelength is large, the size of the antenna required will also be very large. Not just that it will be very large, it will be something which cannot be possible practically. And hence, we conclude that you cannot transmit low frequency signal of 20 Hz to 20 kHz directly through wireless channel. Now, let us give a solution to this problem. The only way I can reduce the size of the antenna is by increasing the frequency, because to reduce the size of the antenna, I have to reduce the wavelength of the signal, and to reduce the wavelength of the signal, I have to increase the frequency of the signal. But the whole purpose of radio communication system is to transmit audio frequencies in the range 20 Hz to 20 kHz. I don't want to transmit any frequency which is greater than 20 kHz because it is not audio frequency. My signal, which is audible to humans, consists of frequencies from 20 Hz to 20 kHz.